Welcome back, everybody. Mr. Renneker here again. And in this lesson, we're going to be learning about the surface area of cylinders. By the time we're done, your main objectives will be to make sure you can find the surface area of a cylinder using a formula that we're going to learn about in this video. We're going to go ahead and jump in to our first big key idea. So here we get our first introduction into how we're going to find the surface area of a cylinder. So in words, we describe this by saying that the surface area, which we'll call S, of a cylinder is the sum, and that's going to be similar to what we did with our previous surface areas, the sum of the areas of the bases and the lateral surface, and that wording is going to be very important. So as we look at our first image right here, we see, of course, a kind of generic cylinder. It says we're going to find the sum of the areas of the bases. So similar to a prism, a cylinder has two identical bases. We have that circle, that flat surface on the top, and then the one hidden underneath here on the bottom. Those are going to be our bases. Even if the cylinder is in a way laying on its side, almost like a can that's been tipped over, the circles are still our bases, which means then that the lateral surface is this kind of bluish outer edge here. Think about it like the label on the can or on a soda bottle. That area would be the lateral surface. It makes a little bit more sense again when we think about peeling apart these outer edges and laying them out flat. If we take a look at the flat pattern here on the right, you can see the two circles, the two bases very clearly here, but then it's this lateral surface that becomes very, very obvious. And again, a lot of us have experience with this idea. If you've ever peeled the label off of something like a can or a soda bottle or any other cylindrical object, you know that when you lay out that label, you get this rectangle, and that's exactly what happens, which means that ultimately, when we're finding the surface area of a cylinder, we only need to find the area of the two bases, those two identical circles, and then we're going to add to it a third surface, which just ends up being a rectangle, and that's not too bad. Thankfully, we have experience finding the area of circles in some of our recent work, and finding the area of a rectangle, generally speaking, is a very old skill that we have a lot of background knowledge about already. Now, when we actually put this into practice, the formula might be a little less obvious, so we're going to go ahead and take a look at the algebraic version of it here. So to find the surface area, the first thing we're going to do is find the area of the bases. Again, since the bases here, since they're both circles, we know to find the area of a circle, we have to take pi times the radius squared. And that's, again, something we've learned about recently. But notice here in our formula, they have 2 times pi times radius squared. And of course, the reason then that we have 2 is because we have 1 and 2 circles. And since we have 2 circles, we just take the area formula for 1 and then double it, just like you guys see here. So that 2 pi r squared, that's going to help us find the area of just the bases. But then you see here on the right of the formula, we have this thing that says 2 times pi times r times h. And that helps us find the area of the lateral surface. But again, going back here to our picture, we say, well, I thought we found the area of a rectangle just by taking its base times its height, or length times width, however we're going to word that. And that's still true. So why does this formula look like this? Why do we have 2 pi r h? Well, that comes in how that lateral surface, it's in how that rectangle connects to the bases. Now, the height of the cylinder right here, that part's pretty straightforward. I mean, the height is going to be height. It is the same h that we see in this formula. But the base length, you can see, is not explicitly given to us. It doesn't just say, oh, the base is this many inches, meters, miles, or whatever else it is. So where are we going to get this base measurement? Where are we going to get B from? And that's actually what you guys can see right here in the picture when it says 2 pi r. What you may or may not remember from our earlier work with circles is that to find the distance around a circle, its perimeter, if you will, or what we call circumference, to find that measurement, we can do it in one of two ways. We can either just do pi times diameter, or we can do pi times the radius times 2, or what we would call 2 pi r. And that's exactly what they're using here. Now, the reason that you'd want to know that circumference here is because this upper edge, or the bottom edge, either one, of that rectangle, it's that edge that actually wraps around these circles for the bases. Or think about it, again, if this lateral surface here, if this was a label, it's that upper edge that would wrap around the can or the soda bottle and touch that entire curved surface. So to find that distance, what we can really just do is find the circumference of the circle, and then we can get that information with actually only two things on our cylinder. If they give us our radius and our height, we can have everything we need to find this information. So that's why they have 2 pi r. That's just the one side length of the rectangle. Yes, it's also the circumference of a circle, but that's why we need it times h. So now that we've got a little bit of background there, we're just going to jump into some examples so you can see how it works and test it on your own. Okay, so in the first example, we're finding just the surface area of a cylinder, and it does ask us, though, to round our answer to the nearest tenth, and that should make sense since we always use an approximation for pi. Let's see how this works out. So the formula for finding the surface area of a cylinder is 2 pi r squared plus 2 pi r h. And again, that means that the only values we need to substitute in are the radius in two places and then the height of the cylinder in another. And so we're going to go ahead and start with that. So I'm going to take 2 pi times r, and in this case r is 4 millimeters, so we'll take 4 squared, plus 2 times pi times the radius again, this time times the height as well, which is 3 millimeters. Now, of course, you will want a calculator eventually to make sure that this work goes quickly, but we actually don't need it yet, and here's why. We're going to leave our formula in terms of pi for a little bit, and I'll show you what that means here next. We would take 2 times pi times 4 squared, but we're actually just going to handle the numbers, so we're going to take 2 times 4 squared. Now, 4 squared is actually worth 16, so we're going to take 16 times 2, which is just 32. And then we take 32 times pi. So that's what I mean by leaving it in terms of pi. Yes, we do still need to multiply 32 by an approximation for pi. We're just not going to do it yet. And into that, we're going to simplify the rest of the side. So again, 2 times pi, which we're not going to do yet, times 4 times 3. Well, I know that 2 times 4 is 8, and then 8 times 3 is 24. So we do have 24, and again, then pi. So everything still has pi in it. It doesn't really seem like we're getting to a good answer, but we're almost there. But what we're really saying here is that we're treating pi almost like a variable, as if it was an a, b, an x, something like that. Like if we had 32x plus 24x, that's how we're going to combine these here. So if we have 32 of something plus 24 more of something, well, that's 56 of that same object, or in this case, 56 pi. So what we get to do is we get to leave this in terms of pi, which helps us use a lot more mental math skills and quick computations to help us get closer to an answer. But now that we're here, now that we only have 56 times pi, we are going to have to go ahead and break out a calculator this time to do 56 times pi, or we're actually going to use, since they do say round to the nearest tenth, that kind of alludes to us using the decimal version here. So 3.14. And hopefully you would have a calculator to do this on your own, but 56 times 3.14 is 175.84. Again, though, they do ask us to round it to the nearest tenth, and the tenths place is right here where that the digit 8 is. We use the one to the right to make our decision. Do I round that 8 up, or do I leave it the same? 4 is too low, so we are going to actually leave that 8 the same. So rounded to the nearest tenth, we should have 175.8, and for surface area, that will be square millimeters. So again, just kind of going back over this idea, guys, as long as you have your radius and your height of a cylinder, that's all the information you need to use our formula here for finding surface area. Next, I'm going to give you an opportunity to try one or two on your own to check for understanding if you'd like. So here are two cylinders. One appears to be standing upright and the other one on its side, but the information is still the same. If you'd like to go ahead and test your understanding now, please go ahead and pause the video, take a few moments to work, and then in a few more moments, your answers will appear again. Just make sure you're ready to round your answers to the nearest tenth. Go ahead and pause the video now. So here you are for number one. If you were successful, you should have gotten a total surface area of 565.2 square yards. And for number two, it would have been 395.6 square centimeters. We're going to take a look at one more idea before we wrap up our work with cylinders here. And one of the other common skills that we're going to do with surface area is thinking about not all of the surfaces, which seems a little counterintuitive. In this example, it says how much paper is used for the label on the can of peas. So when you look here at the can, of course, we have our three main surfaces. You have the two bases, the circle on the top, the circle on the bottom, and then you have the lateral surface or the rectangle that is here on the side. But notice here that they say how much paper is used for the label on the can. Well, there is no label on the top and certainly no label on the bottom, which means the two circles aren't actually our concern. So when we go back to our key ideas around surface area, for a cylinder, we see here, at least in the algebraic section, that the formula is actually split into those two main parts of a cylinder. You have the areas of the bases, that's the 2 pi r squared, and then you have the area of the lateral surface. And when we think about the can, all we're really trying to focus on is that lateral surface, which means the first part of the formula is not going to be used at all. Again, because there's no label on the top or bottom of the can itself. So for us to find the surface area of just the lateral surface, we're only going to use the 2 pi RH, which we see back here. So we still will need the radius and the height to substitute in our formula, but other than that, we only have to use half of the formula in a way to answer the question here. So we will go ahead and substitute in our values: 2 times pi times the radius, which is 1 inch, times the height, which is 2. Again, we're going to need to combine just the numbers, so 2 times 1, which is 2, times 2 again, which is 4, so we end up with 4 times pi. So again, I left it in terms of pi, but this one going as quickly as it can will just ask us to finally get a calculator and take 4 times 3.14, which is 12.56. And in this case, that'd be square inches. Notice we're not asked to round to the nearest tenth, so I don't need to worry about that. And we are all set to go. The amount of paper that would be required for our can here is 12.56 square inches. So really, that's the big idea behind surface area here, understanding that a cylinder has three surfaces, which is comprised of two bases, which is two circles, and then the rectangular lateral surface. I would make sure beyond the examples and work you tried on your own that you have these key ideas in your notes for you to refer to as you work. Now that we're all done, if you feel like you're able to find the surface area or try to find the surface area of a cylinder on your own, you guys are all set to go. You know to reach out to me if you need any extra help. And as always, I will see you guys next time.